number, you can use a test which is called as one sample t-test. So to do this one sample t-test, what I will do is I'll just show you a data set, right? I can't show all the data set in all the analysis in one data set. So let me just can you see this data set, everybody? Right? I have shared this data set. Yes. Correct. This is the problem. You have machines here. Correct. So there are inspectors. These machines are designed to make disc brake diameter. Sorry, they are responsible for making brakes, and each of these brakes has a diameter, right? So we are interested in checking whether the average disc brake diameter is close to 322 or not. Is the problem statement clear? So the 322 is like that class, the student getting 50 marks or something, that becomes the benchmark. If the average disc brake diameter is very close to 322, it means that the process must be in control. If it is not, then we are in problem. Is this clear? So the first column is basically the machine number. So there are 8 sets of machines here. Can you see here? There are 8 different sets of machines, and they have taken 8 samples of machines, and they are measuring the disc brake here, 322 mm, 322.05, 322.022. Like this, they have calculated the disc brake diameter. So we will be using the one sample t-test to check whether the average disc brake diameter is 322. Why are we not using chi-square test here? Are we finding out relation? Relation means two variables. There is no relation here. I am just comparing whether the average is equal to some value 322. Tomorrow I want to find out in India the average number of COVID incidents is, let's say, COVID infections was, let's say, 3,000 per day. I'm just giving an example. I want to check whether in Karnataka the average number of infection is 3,000 or not. If it is more, it means that we are doing worse than the country. If it is less, like Maharashtra, it was doing worse than the country. Right? If it is less, it means that I'm doing a lot better than some of the other states. If it is very close to 322, it means that I'm on par with the country. Correct? Is this understood as to why we are using one sample t-test? So this data set I've already given. The name of this data set is brakes data set. Right? So let me open up Python. NumPy, SciPy, and Pandas. I think SciPy you have already installed, so don't worry. Just worry about NumPy and Pandas. If you install these two things, Pandas also you've installed. So just import NumPy as NP. That should be fine. Import NumPy as NP. Right? Let me just scroll down. Now I will be importing this data set. Right? Again, you can copy paste this code from the earlier customer satisfaction data set. All right, just copy paste the same code. Just replace the name with breaks.csv. You can replace it with breaks.csv. There are two columns, machine number and diameter. Second column is the diameter column. Second statement, it is not required, sir. I mean, you can just, there are only two variables. You can ignore it. Ignore it. Don't worry about it. It is not necessary at all. Now we will be performing the one sample t-test. Very straightforward with one variable. OK. So to perform this, the command that we have to give is as follows. You can see here stats dot, right? Make sure that SciPy is imported as stats. There is a function which is called as t-test_1sam. t-test underscore one sample. Here I'm accessing the variable break. Yeah, yeah. So are you able to understand this population mean? Here I'm specifying 320. Tomorrow for a different problem, if you want to specify 50 or 60, use the same code, put a comma, population mean is equal to 50 or 60, whatever number you want to check, you can check. Correct? Now, when we are doing this, we are getting the statistic value. Remember earlier also we got chi-square statistic value. This is the T statistic value. Correct? I ignore this. I look at the P value or the probability value. What is the P value here? It is 0.03. The probability value is 0.03. What is the decision criteria? We took the P value, compared it with 0.05. Is 0.03 less than 0.05 or greater than 0.05? It is less. Less basically means that the average disc break diameter, right, is significantly different from that of 322 millimeter. Are you clear with this? If you want, I'll just quickly, can I just break this down? Correct? Ideally, what is happening is you have what is called as null hypothesis. Yes, benchmark P value less than 0.05. There is a significant difference between our company and the industry standard. This is a general example which I have given. Yes. 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 So, yes. There is a difference in the average disc break diameter as compared to 322. It is significantly different from 322 millimeter, which means that the process is out of control. There are certain problematic machines here. Which are these problematic machines? That's another level of analysis which we have to do. Yes, is different. Different. Because here we are trying to find out correlation. Here we are trying to compare whether the average disc break is closer to 322. If we would have got a P value greater than 0.05, what will we say? The average disc break diameter produced by these machines equals 322. If it is more. Now what is the P value? I'm getting a P value less than 0.05, and therefore I will say that the average disc break diameter produced by these machines is significantly different from that of 322 millimeter. That is very less than, right? Just 0.05, you are saying that it is very close to 2. It is less than that, you are saying. Again, I'm telling you, right? See, when we are looking at the P value, what did I say? P value is a tool which tells me whether there is statistical evidence for me to conclude that there is a significant difference or not. So there is less than. So when you look at 0.03, what is this 0.03? If you look at our decision criteria, it is less than 0.05. Less than 0.05 means what? less than 0.05 means basically there is very little chance that this has happened accidentally, and there is more chance that there is a scientific evidence behind this happening. And therefore, we are saying that there is at least 95% chance that the average disc brake diameter is significantly different from that of 322 millimeter. Very simple. See, p value lying between 0 and 1. It will, right? So we are comparing it with what? 0.05. So this is 0.5. When we are looking at 0.05, it is somewhere here. 0.5 plus 0.5 is 1.0. So half of this is this. We are looking at 0.05. So it must be somewhere here. This is 0.05. Right? Now, when we are looking at 0.05, compare this number. Level of significance is 0.03. Right? If the p value is less, it supports rejection of the null hypothesis. High p value support acceptance of the null hypothesis. Very simple thumb rule. If I have to break it even further, just remember this thumb rule. We always say, if people get confused, what do we say? We say if p is low, null will go, we say. If p is low, null will go. If p is high, null will fly, we say. Yes. Yes. Impurities, yes, yes. It's okay. Yes. Impurity should be lesser. Yes. In both cases means what? Which two cases you're talking? Chi-square. There I'm trying to find out relationship. Understand here. See. Let's say this is my null hypothesis here. This is my alternative. Here I'm saying that no relation. Here I'm saying the alternative is that there is a relationship. Correct? What is the p value that we got there? The p value is 0.17, which is greater than 0.05. Right? P value is greater than 0.05. Right? Greater means what? What did I say? If it is low, it supports rejection. Automatically, it means that if it is greater, we do not reject. So I'll have to go by this and say that there is no relationship between the two variables. That is what I have said. Here, this is about a relationship. Clear? Now, what are we talking about? Now we are talking about comparing means. This is t-test, right? So this is t-test. Here again, we have H0 and H0. What is H0 here? The average disc brake diameter, correct? The average value of disc brake diameter is 322. Alternative is that the average disc brake diameter is not equal to 322. Null alternative. What is the p value here? 0.03. Correct? P is equal to 0.03. Is this less or greater? Clearly, it is less than 0.05. Lesser means what did I say? It supports rejection. So reject this and say that the average disc brake diameter is significantly different from 322 millimeter. Null, we say, if you null is dull, we say. Null hypothesis is dull hypothesis. Dull hypothesis means it is the hypothesis of no change, no relationship, right? There is no difference. It is the same. It is the hypothesis of sameness. Every day I'm wearing white shirt only. This Saturday, next Saturday, third Saturday, fourth. It is the hypothesis of sameness. So here, the average disc brake diameter is the same as 322. What is one thing, right? Here I'm saying that there is no relationship. They are completely independent. So null hypothesis is the hypothesis of no change, no relationship, no difference. There's a simple thumb rule that I can give. Once you frame the null, alternative is exactly opposite of that. Alternative is there is a change. There is a change. There is a difference. The number that you're getting is different from 322. I don't know. It can be 323, 330, 340, 322.105. I don't know. Alternatives can be millions. Null is always one single thing. We have fixed at 322. This is the definition. Once we frame this, then you look at the p-value, compare it with 0.05. If it is less, it will reject, straight away reject. If it is more, do not reject. As simple as that. First problem. H naught, right? Yeah. Do we define H naught as no relation? Yes. That's why I said go back to the definition. What is the definition of null hypothesis? Null hypothesis is a dull, something which is boring. There is no relationship. These two variables are independent. They're completely independent. There is no relationship at all. Right? Alternative is something which yes, there is a relationship. You can't interchange it. Problem. In the first problem, we did not reject the null hypothesis, correct? No, we did not. Because it is greater than 0.05, we did not reject the null hypothesis and concluded that there is no relationship between the two variables, store ID and customer satisfaction. Again, in the first one, we said there is no relationship. Yes. And in the second problem, t-test we are doing. Yeah. Here it is t-test is designed to do a completely different thing. But the hypothesis, sorry, H0 statement can be same. H0 means basically average. Here t-test is used for averages. But null statement. Yes. The statement here is that the average disc break diameter equals 322 millimeter. This is the assumption that I'm making. Sure, sir. I'm only studying with the defining the H0. Average is equal to 322. One number. Case, we said no relation. Yes. Yes. But in the second case, why we also cannot say average is not equal. Why that cannot be another? See, yes, correct. See, null hypothesis is usually one single thing. Here I'm saying it is 322 only. It can't be different. Alternative can be multiple things. It can be, when I say average is not equal to 322, it can be 323. Alternate can be several which cannot be captured. So simply I'm saying unequal. And it cannot be interchanged. Null is always one single thing. Remember it like that. Sure, that part is clear. Yes. I'm only comparing H0 or H0 definition for two problems. Correct, correct. Here when we say there is no relationship, they're completely independent. Here when we say relationship, now is there a relationship? There could be several possibilities here. Is there a positive relationship, negative relationship, strong relationship, weak relationship? So many possibilities are there. Alternatives are usually several things. Null is always one single thing. There's a simple thumb rule which I'm giving so that you understand. Null is always one single thing, right? Right? Null hypothesis is the hypothesis usually of equality also we say. Equal to 322. Equal. It is equal to 322. Right? Maybe you are able to. Online, are you able to understand?
Yes, sir.
Yes, 322 is our number, which we are adding. Because here the problem statement is to check whether the average disc break diameter produced is 322 millimeter or not. Tomorrow, if you're checking for attrition rate, you want to check whether it is 10% or not. So 10 divided by 100, 0.1. It is, you can supply that number depending upon the business problem that you are solving. It is under your control. Is completing the and then it is calculating. Yes, whether there is a difference or not. That difference, whether it is significant or not, that is what we are checking. All the machines, yes. All the machines. Entire data itself I've taken, I have not filtered anything as it is. So it means that all the 8 sets of machines and their data is included. Right? One sample data, right? This is like what you are comparing the child's performance with the average performance in the class. Yes, 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 please, yes. This the data set the problem statement question says for the given data set. My company rates are bigger than industry standard. Okay, one question. Yes. Second question, in my company rates are equal to industry standard. Yes. Both these two cases. Yes. How will you define this one? Yes. So in this case, the second is a lot easier because we have already discussed this. Correct. Whether it is equal to 322 or not. Correct. In the first statement, if you actually compute the average, right? So this we are comparing the population mean we are taking is 322. Okay, right? Now you are checking whether ours is bigger or less than this. Just bigger or not, just tell me is the problem. It is bigger or not, right? What we can do is you can just simply go to your disk, that source file of breaks, correct? This is the sample mean. If I select this data, what is the average that you're getting? Can you see the average here? 322.00201. So it is bigger. No, we will be doing a t-test. So when we are getting a to answer your question as to whether our the disk breaks that we are producing by these machines, is it bigger or not? You'll be doing everything is the same. But your answer is that it is bigger. The average disk break diameters that we are producing is bigger as compared to the value of 322 millimeter. Because this is the for the sample mean. This is the sample mean. But when we do the t-test and how we can apply t-test? Same thing. Everything will be the same thing. But because that additional piece of information is asked, ours is bigger or lesser. All that you will be saying is look at the average mean of the sample. Right? Here we are getting it as 322.00. Therefore, we are saying it is bigger. If this were to be, let's say, 320, then you would have said that ours is smaller and therefore there is a significant difference. See, t-test is used to just compare whether there is a significant difference between sample mean and population mean. So this is the sample mean that you have. The population mean across is 322, which we have specified in Python. So when somebody says basically to your, come back to your question, is our sample mean bigger or smaller? All that he's asking in a simple layman language is basically check in the data set for our sample of 8 machines. Is it exceeding or is it not exceeding? So just take a Excel average. This should come to 322. So this 322.2 is anyway greater than 322, right? So our sample mean is actually greater. And therefore we are getting a significantly different result. There is a significant difference. The p-value is less than 0.05, and that though the sample mean in our case is bigger, and there's statistical evidence to prove that the average disk break diameter produced by these machines is bigger as compared to 322 millimeter. Yes, yes, yes. Because that was not when we have to come up so that we can decide whether there is a significant relationship or not. Yeah, yes. Right.
But here in this case number, same thing can be done using mean also. Clearly mean is more than the 322.
Yes. Yes. But what is the see? We are not just comparing 322 with 322.20.
In terms of percent.
322 and 322 point something. Last time also, I think I sort of told you that in statistics, we are working on the sample and then we are projecting the conclusion to the population. So let me just show this. We have taken a sample of 8 machines. Right. 8 sets of machines, whatever, right? So this is sample 1. In this sample, we have how many observations? 400. Count is 129, right? It's actually 128 because if you leave out this label, it is 128. So here, when you take the first sample of 128, what is the average value that you're getting? 322.002 something, correct? Let us say the inspector, the people who are inspecting this, they take a different sample. This is our sample 2 for 128 at a different time point. This is taken, let's say in the morning, 10 o'clock, they have taken this, 10 a.m., somewhere around, forget the time, at some point they have taken, this is the second sample. Now here, the average can be 350 possible. It can be any number. Correct. Now let us say I will take one more sample, which is sample 3 of again 128 observations. This is, let's say, at 10 o'clock, 10:30. This is at 11. Here, the sample may be 321. I'm going to take the 4th sample, 5th sample, 6th sample. I can take 100 such samples. This is sample number 100. Here again, I will get some value. X bar is equal to 322.35. Which sample will you go by? How can we say that? That's if I take 100 samples, I'll get 100 values, 100 different values. If I take 100 samples, 100 times I'm taking a sample of brakes. The average, if I check, I'll get sometimes I'll get more, sometimes I'll get less, sometimes it can be same thing. On what basis will can I put all the faith and say that it will always be 322 point what is this? 322.00. This is the average that I am looking at in Excel. 322.0, which is greater. There is no evidence for me to. Usually, what we do is we take one sample and we have visibility towards only one sample. We leave out the 99, the remaining 99 samples. So this is where your p-value steps in. So this is where your p-value steps in. And then it helps me make a decision wherein it says, if you take 100 samples, at least in 95 out of these 100 samples, the average value will be a number which is greater than 322. In 5 of these samples, the value can be anything. It can be equal or it can be less than. When we are using P equals 0.05, there is a less than 5% chance. Less than 5, that's what I've been saying. There is a less than 5% chance that the average disc brake diameter will be smaller than the value of 322 point whatever. There is less than 5% chance. Therefore, if you remember the earlier null hypothesis that I have rejected my null hypothesis and I've concluded that I've made a generic statement saying that it is different from 322. If you want me to be more specific, now I can confidently say, because it is working on this data set and it is higher. There is less than 5% chance. Sorry, the p-value is 0.03, therefore it is less than 0.05, and we can now come to the conclusion that the average disk break diameter will be higher as compared to 322. So we are not just doing one sample and then compare. What you are doing is basically 321, it is greater. It is not that. That is something which I can do manually also. You're right. I don't need this p-value approach at all. I don't need this p-value approach. What the p-value approach says is, if you keep repeating the experiment 100 times, at least 95 out of 100 times, you expect to see a result wherein the sample mean is significantly different from that of 322. 5 times because of a bad sample. I may get a bad sample. I may get a contrarian result. That we can't give a guarantee because we are statisticians. 5 times we can go wrong, but at least 95 out of 100 times you expect to see the average disk break diameter on the higher side as compared to 322. It will be greater, it can't be less. It will also not be equal. That is the essence of your p-value, because that's why I'm saying 0.05. Automatically it means that 100 different samples if you take, out of 100, at least 95 out of 100 times, you expect the average disk break diameter to be significantly different, and it will be higher, not smaller. Which one? In this case, if you're so sir was giving two problems. First sentence, basically he said that in case I want to check whether it is 322, you do it like that. If the question is basically, I want to check whether it is bigger or smaller. Usually you don't get the problems like that. Even if you get the problem like that, fix the null hypothesis as H0 and H1, go with the flow, and then basically look at the sample average, whether this is bigger or not. Accordingly, you can conclude. If this were to be smaller, let us say, right, instead of 322.00, let us say I would be getting 321, simple number I'm taking, which is less than. So what will be my conclusion? I will again look at the p-value, and I will simply conclude that the average disk break diameter is significantly different from that of 322. If somebody asks, sir, is it on the higher side or is it on the lower side? First, look at the sample average. This sample average is 321, which is less, and therefore now you can say that it is significantly different and it is lesser than the value that you are checking for. Yes. It tells us that the machines are the entire process, the disk break, these machines which you're using to produce the disk break diameters, they are out of control. They are not manufacturing your disk breaks which are conforming to 322. We can't have a disk break diameter which is exceeding 322. We want it to be close to 322. So if it is higher, so they will have stipulations, correct? You can't have a disk break diameter which is larger, which is smaller. We don't want this. Now we have to go back to the machines and check whether these machines basically, is it because of power outage, or is it because the spare parts have got worn out? Some certain parts have gone worn out. Is it because the staff members are not taking proper care? That is what we need to do as a second step. Right now, we can say that the process is out of control. It is not in control. Had it been 322 or close to 322, I could have said, yes, the process is meeting my standards of 322. Then we are safe, right? That is what we want. The matter ends there, right? Yes, yes. We are saying because that's what we are checking for. What is the problem statement? The problem statement is to check whether the average disk break diameter equals 322 millimeter or not. Why 322? Why are we fixated with 322? Because by that logic, the process is in control. If we are getting disc break diameter which is different from 322, then it means that the process is out of control.
But there is an entire population, then there is no civil or anything, nothing is.
Yes.
This entire population is finally very few guys. This is anyway more, and then restrict
Yes.
now, example, from one sample, we're trying to predict this what my observations can I make it hundreds of similar
Yes.
samples.
Yes.
Yes.
Yes. So that my final result should not be sample specific result. If it is a very, very sample specific result, then I will spend the entire day, taking, going there, take a sample. Next 4 o'clock, go and take a sample. How many samples can we manually take? It becomes very, very difficult. Any conclusion that we are making in statistics, it should be generalizable, which means that even if the sample changes, by and large, are you confident that the final result will still hold? If you say yes, to what extent? We can say 95% we are confident that you take the sample 100 times, 95 out of 100 times, you expect to see a sample mean which is different from 322. That is a simple conclusion that I can draw.
This case, same example.
Yes.
What
If P is more than 0.05, what did we say? If it is smaller the value, supports rejection. Greater value, support acceptance. So I will accept my null hypothesis and conclude that there is no significant difference in the average disc break diameter as compared to 322. In simple language, it is close to 322. That's what is my conclusion. Huh? That's a good thing. The process is in control. That's what it means. But we are getting a value which is different. That's what we are saying.
then we have to investigate why it is less and
What has gone wrong? Is the process in control or out of control? If on an average the machines are producing a disc break diameters which are close to 322, it's a good sign. I'll be happy. But here there is something wrong, and therefore we are getting p-value of 0.03, which is less than 0.05. And therefore the average disc break diameter is significantly different from 322. That is what statistics says. So if the average disc break diameter that is produced is significantly different from 322, we have to question this process. What is wrong with the machines? What is wrong with the staff? Is it because of power outage, or what has happened with the entire system? We have to look into the entire process here. If it is close to 322, the matter is over there. I have got nothing to say. It's a good thing. All the machines, most of these machines are doing a good job. I'm getting uniform machines, more or less. It is meeting my standards. In your case, yes. In your case, if the process is in control. In control or out of control, you understand, right? Out of control means what? Sometimes because of power outage, some of these machines may be old machines. They have not been greased properly or serviced properly, and therefore they may be malfunctioning, and therefore some of the values may be higher or lower. And in fact, this is one piece of it. When you do ANOVA and such things, you'll see that machine number 2 is the one which is the problematic machine. Out of all these things, when you check, this is one part of it. We have firstly come to the conclusion that out of these 8 sets of machines, correct? 8 of these machines can be, 7 of these machines can be doing well. One problematic machine could be there, or 2 could be there. I have checked this. Now we have not discussed this. Which is that one problematic machine? That problematic machine happens to be machine number 2, which is basically going out of control. Because of that one machine, the entire process is getting failed. I've checked that. Are you able to understand that?
Getting more than
very easy in the sense that why are we not getting it? We didn't get it in this case, right?
then your whatever input you can do. probability which is more than very easily.
P value is talking about sample repeatability. If you are already sure that, okay, if the, let's say you're taking this, forget this P value, T test, everything, correct? You have taken a sample and you are seeing the value, average value is 322.0. And you feel that, sir, it is not a big difference. Don't use your T test at all. You don't need to use if you're so sure that this is holding good. But then you'll have to answer a few questions. What is the first question? Was you have taken this one sample at 10 a.m. What if you take the sample in the evening? Will the result still hold good? If you take the sample in the afternoon, will the result hold good? Then you'll not have an answer. If you repeat this experiment 100 times, question is at least 95 out of 100 times will the result still stay or not. If you're so sure that, sir, with one sample itself I can make a conclusion, then you don't need a p-value at all. You don't need the p-value approach. 322 is the expected value. For your sample, you're getting around 322.00. Manually, I can see that, okay, there is not much of a difference. I'm happy with this. You take it. But the risk is that that kind of a conclusion is sample specific. With one sample itself, you are coming to that conclusion. What if the sample changes slightly? You will not have an answer. Right? To answer that question, if the sample changes, what happens? I will be looking at my p-value, and based on the p-value, I will be saying if this experiment is repeated on 100 times, at least 95 out of 100 times, I'm confident that the average disc break diameter will be significantly different from 322. 5 times it may be very close. That is the limited point that I can make from this exercise.
So the closer one are accepted.
Closer one means what?
In 5% case, you are telling that very close.
It can be, I'm saying. At least it can be close. It can be one sample.
Which is good and
it depends upon the objective, isn't it? See, in this case, let me just write the null hypothesis. What is the null hypothesis here? What is the H naught here? The average disc break diameter is equal to 322 millimeter, correct? Right? Average disc break diameter is 322 means what? More or less the machines are producing disc brakes whose average more or less they're very close to 322. Now, if I'm a manufacturer, if I am in this particular factory, don't I want my disc brake diameters to be consistent? Yes. So this is a good thing in this case. Why do I want a machine once it is manufacturing 322 point something? Sometimes it is making less. If it is inconsistent, that's a bad thing. So in this situation, alternative is a bad thing. This is a good thing. Null hypothesis is a good thing here. That's why I'm saying this is a good thing. The average more or less is coming to be 322 millimeter. If you accept the null hypothesis, then it's a good thing in this experiment, and that depends upon business. Every problem, it depends upon the business. In this case, if the average of the disc brake diameters is very close to 322, I'll be very, very happy. It is consistent. The process is consistent. It is doing very, very well. And I have got statistical evidence also to say that it is close to 322. If I get the p-value greater than 0.05. But here I don't have that statistical evidence for me to say that the process will be consistent. Because my p-value, as you have seen just now, is less than 0.05, and therefore I will have to reject my null hypothesis and conclude, boss, there is something wrong with the process.
here is the catch, right? So we're saying less than 0.05, we're rejecting, right? So it is not.
Yes, it is not good. My if you look at the what is this value here? 0.03. P-value is 0.03, correct? It is less than 0.05.
We're giving more chance to accept it, right? We're giving 95% chance to accept
Why will I give more chance to it? See, understand the fundamental concept of p-value. P-value is used to either accept or reject. Here it is 0.03 means what? Is it less than 0.05 or greater than 0.05? Less. So less means basically I have to reject this. If I reject this, it means that the average disc brake diameters produced by this set of machines is significantly different from 322. It is not meeting my expectations at all. It is different from 322. Had I, that is a different case, but what am I getting? That is what I'm looking at. This is indicating to statistical evidence. Is there sufficient statistical evidence for me to accept or reject? Because it is less than 0.05, it means that there is sufficient evidence for me to conclude that the null hypothesis is false.
Last time.
Yeah.
So in this case, whatever mean we are getting, for all the 322, 002, but we are not expecting even that. We are expecting even lesser than that, which is
Very close to 322. Very, very close. That is what
even
that is also not good. Okay. Shall we make a move on to the second problem? This is also, see, when we say t-test as it's a family of t-tests we say. This is what is called as one sample t-test, wherein I'll go back to that example of a child, wherein I compared her performance with that of the class average. Now, the second could be, the second type of t-test is, let's say she has got very bad marks in midterm. So what do? I'll give her a test. Sorry, I'll give her a tuition, right? If the student fails consistently, we tend to give tuition. And then we look at the second set of marks. If the tuition teacher is also bad, if he is also not doing well, and this, maybe the child herself is done, so tuition may not have much effect at all. Afterwards also you may see a same result, or there may be drastic difference. So here you have a pair of variables, but it is before and after. Let me give you some example. If you want to check whether there is a change in the blood sugar level of a patient before taking breakfast and after taking breakfast, whether there is a significant change before and after for the same set of people. Or let us say you want to check whether there is a change in the weights of the patients before giving a drug and after giving a drug. Wherever you have before and after kind of a situation, three words, before intervention and after intervention, you use another kind of test, which is called as paired samples t-test. Right? In that example, what was it? Before tuitions, what was her performance? After tuition, what was her performance? If there is a change for the better, it automatically means that the tuition is effective. If there is no change, it means that the tuition is ineffective. Correct? So this is the second type of t-test. We finished the first, right? Now here, I'll just be calling this as paired samples t-test. Right? Correct. Shall we do a paired samples t-test? Now let me just show you the data set firstly. Correct. Are you able to see this data set, everybody? Are you able to see this data set? This is patient IDV. Here the problem statement is diet study. Diet study, I shared it with you. OK. See, there are patients here. How many patients are there? There are 16 patients. Can you see here? Their age is given. Their gender is given as male or female. OK. Are we clear with this? Now look at this TG0, right? Don't worry about TG0. TG stands for triglyceride level. Triglyceride level. We will not be working on this, but I'm just telling you. They have taken 5 different measurements of triglyceride level. Here, when I scroll to the right side, you see weight 0. You see here. Let us say I want to reduce my weight. I first go to the doctor. As soon as I go, he'll make me stand on the weighing machine and he'll record my weight. So this is the initial weight. WGT0 is the initial weight of the patients. Is that clear? Right. Then what is happening is basically these patients are given medication, some tablet or some whatever treatment they're given for weight reduction. And at the end of the first week, after giving medication, they're recording the second level of observations. This is weight 1. This is initial weight before treatment. This is weight after first week. You're recording the second week, right? You continue the medication for the second week, and at the end of the second week, you note down the third level of measurement. Initial, first week, second week, then continue third week, and at the end of the fourth week, you note down the last level of measurement. What is the problem statement here? The problem is to find out whether the drug is effective or not. When can I say that the drug is effective? The drug will be effective if there is any change in the weights of the patients before treatment and after treatment. Just remember 3 words: before and after. Any problem in the world which has before and after, before treatment, after treatment, before tuitions, after tuitions, before campaign, after campaign, for all these situations, right, you can use what is called as the paired sample t-test, right? Look at this. Here, I have got one set of patients, correct? Can you see 16 patients? But we have multiple levels of measurements taken at different time points, correct? For this, we are going to use which test? Why can't I use the chi-square test here? Your answer is chi-square is used when you have 2 categorical variables. Where are the categories here? That's it. There
Here
are no
we are not
categories here.
finding
Am I
the
finding out
relationship.
relationship between the weights? Weights will obviously be related. I am not interested in that. Is there a change in the weights of the patients before and after treatment? That's a limited point that I'm making. This is not a relationship based problem. Am I checking whether the weight reduction is X 320 to 100? So therefore, I'm not using one sample t-test. My problem is there a change in the weights of the patients before treatment and after treatment? Before and after, that is your clue. In chi-square relationship and categorical variable, are there categories? That is the clue. That is the biggest hint. Sorry, somebody was saying something. Yeah, I'll come to you. Yes, please. Yes, online, somebody wanted to say something. Sorry.
No, I said it's not based on relationship. When
Yes,
you
you're
ask.
right. You're absolutely right. There is no relationship. We are not checking any relationship. Yes, sorry.
Very
No problem. Please ask me.
marginal. Just when we take C and D, then we get
We take C. C is categorical, but D is not categorical. They're right.
all the names we can put a sum and male versus
See, male is there. Triglyceride level. If you take this triglyceride level and categorize it as low triglyceride and high triglyceride level, are you able to understand?
Yes.
Below this some threshold, I can say less than 150. I'll call this as low triglyceride. Above 150, let us say I'll have high triglyceride. Then it becomes a categorical variable.
general of category.
Correct.
Correct. Here, low and high.
Then you can check. Then you can do your. But what is the interest there? Is there any relationship between gender and triglyceride level? It might not make sense. But I understand what you're.
Yes, very
Yeah, sure, sure. But you can always do that. It's a good point, because if you have measurement, many times it may not work. Yesterday, some time back, we had this one person asked me, sir, what is it? Temperature should ideally not influence COVID cases. I'm just giving an example. Temperature, whether it is high temperature or low temperature, that should not influence the number of infections. But when we did analysis, we were getting that there is an influence. So he sent me a WhatsApp. In by that case, so places like Saudi Arabia and such places must have very, very high COVID cases. If temperature is the determining factor for COVID cases. But he's a scientist in this, and he says it cannot be that temperature and this are influencing. Then what we did is basically that temperature factor is there, right? We converted into a categorical variable. Low temperature, moderate temperature, high temperature. COVID cases also, we looked at low incidence of COVID cases, moderate incidence, and high incidence of COVID cases. Now we have got two categorical variables, temperature class, COVID class. Now when we found out the relationship, it was completely independent. Then he was also happy, sir, this makes more sense rather than just taking the variables as it is. So this is basically your feature engineering, manipulating and such things, load, right? So a scale variable can be easily converted to categorical variable, but a categorical variable cannot be converted back to scale. It's a bit difficult. It's a different, right? I'll come back to this. Here before and after, right? I've given this data set. I'll close this. I will be coming back to Python. I will be coming back to Python. Right? Shall we quickly import the data set? Yes, yes, yes. That study data set shall we import? All right. You can just copy paste this. I'm just working on the weight variables. Multiple in the sense?
Just before and after
One set, yes, yes. Yeah, why I'll tell you, because see, if you can ideally speaking, the way I will be solving this is, I will be comparing the initial weight with the final weight. Right? That is one level of comparison. Right? And if we find that there is a difference, then it means that the drug is effective. One more question at this point is, the drug is effective, no doubt. But the question is, from when has the drug begun to take effect? Some drugs, they start giving you effect immediately. So therefore, one more level of t-test, which is optional, I want to do is initial weight and the first week weight. Is there a difference? Initial weight and second week, is there a difference? Initial weight and third week, there is a difference. We can do multiple levels of paired samples t-test.
like paired sample test.
Yes, only two. At a time, you can take only two. Yes, yes. No, you don't need to ignore that comment. It is just optional. I have done this. Okay. Paired samples t-test. Here, stats dot t-test underscore related within bracket weight 0 versus weight 4. Correct? As you're on the same page, everybody? You getting this right? Any problem? Okay. Should we try to interpret this? Initial weight and final weight we are checking, correct? Yes, please. Yes. There is no difference. There is no difference. Or the hypothesis of the same thing, equal. Initial weight and the final weight is the same. If you equal to, put an equal to, initial weight and the final weight is the same, whatever be it. Which, if the initial weight and the final weight are the same, it means that the drug is ineffective. Okay. Right. So as before, we are getting a P statistic value, and we now will be looking at the P value. What is the P value we are getting? Sorry.
Very close to zero.
Yes, very much close to zero. Right. Right. So this is a very right. If you see here, it is 1.13 into 10 to the power of minus 8, is it? Okay. So 0.00000, almost 8 zeros, correct? And then you have some large number, right? So I can pick up the first two numbers, which is 0.00, less than 0.05, less than 0.05. I will reject my null hypothesis and come to the conclusion that there is a significant difference in the weights of the patients before taking drug and after taking drug. Before and after, there is a significant difference. Yes, right. Correct. Yes, there is no change, no relationship like that. Right? It's always one here.
Bad.
Why are we saying bad? That's a very subjective assessment, right? What is bad for you might be good for me. So we are not saying bad. We are saying null is dull. It is the hypothesis of sameness, constancy, no relationship, independence. Those sort of things are in null hypothesis. No effect, no change, no difference. Alternative is there is a change, there is a difference. Alternative, there is a change, there is an effect, there is a difference. Those sort of things go under alternative. And alternative can be several usually, right? Yes. Yes, we reject null hypothesis and conclude. Yes. That's it. That's sufficient. Now, we have learned benchmark analysis, paired sample t-test, right? Now, the third type of t-test, one sample t-test, paired samples. Now, the third samples t-test. In that girl's example, which I was talking, right? Neighbor's performance with your girl's performance. Neighbor is another person, your child is another person. So if you want to compare between two groups, is the salary for two genders the same? Is the output for Andhra Pradesh and Karnataka the same or not? That is what is called as A/B testing. A/B testing, and the word, the idea of A/B testing and such things are exclusively used in digital marketing, particularly for website analysis. In a website, correct, what happens is that a lot of people, they, let's say we have the Reva website, Race Reva website. There is a certain look and feel of that. And we are actually monitoring the traffic flow. How many people are coming, watching my programs? How many people are subscribing? How many bought it? These are all some of the things which are monitoring. Let us say it is pathetic, very boring. Now, what will I do? I will change the look and feel. You can change the website look, correct? Instead of having some video there, I can just maybe have it right at the left side. And all my programs, AI, BA, CS, I'll put right at the top so that it is eye-catchy. I can just have a friendly sign-in page. I can reduce the text and I can have more pictures. So how many variants you have? You have the A variant and the B variant. Right? Or you, whenever you might want to compare between males and females. I'll give you another example. In the field of medicine, what happens is that if you want to find out whether the drug is effective or not, how do they usually do it? Usually, if there are 100 patients, what they do is they'll not tell this to the patients. This is internally done. If there are 100 patients, right? These 100 patients are divided into two groups. One group is called as the control group, and the second group is called as the test group. Control group and the test group. Correct? Control group may be 30, test group will be 70. To the control group, I will give what is called as a placebo. You would have heard of placebo, the word placebo. Placebo or a sugar pill. It's like a sugar pill. But I will lie to them saying, this is a wonderful medicine. It has all the medicinal properties. It is just a sugar pill. It has got no medicinal properties. I will give it to them, but right, it's a wonderful medicine. We have gone to Himalayas. We have done 17 years of experience. We'll give it to what is called as the control group. To the test group, we actually give the new medicine with that medicinal properties. Control group and test group. Correct. Now, after 3 or 4 days, if both of them come back and say, on an average, 30% people here and 30%, sir, your drug worked effectively, what does it mean? Yes. So this person, it is usually the psychology, which is because of psychology, you have sort of improved. It has got nothing to do with the medicinal properties because there is no medicine at all there. It's as good as saying that the new drug is the new drug is on par with the old drug. Correct. So this is called as control versus test. These are two independent group of people. So let's say Amin, if Amin is in the control group, he can't again be in part of the test. Either you're there or you're here. You can't be in both the cases. So they're mutually exclusive groups. If Amit is in part of test, he's only there. If Sir is part of control group, he's there. So these are two mutually exclusive groups. First group is called as the control, or sometimes you can just call this as the A variant. Second group is called as the B variant. So you're comparing whether the time to recovery of these two groups is the same or is it different. If the time to recovery of the second group is lesser, In this case, it means that the drug is actually effective because it is outperforming the placebo without any medicinal properties. If both of them come and say that it is the same, it means that the drug is hopeless. Correct. Naturally, only a person can be healed. Why do I need your medicinal properties and all this? I don't need it all. So this is what happens in the pharmaceutical companies exclusively, wherein the group of cohort is divided as control and test. One group receives the drug, the other receives placebo. It is called as placebo or simply a sugar pill. But you'll say, yes, 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 it's good. It's a fantastic drug. Whatever. Yes, could be. That is how the drug will, only if this is outperforming this, then you have a strong case saying that the drug is effective. Right? The test group and the control group. Even in campaign analytics, people spend money. But what is the guarantee? Sir, I've got 4% after launching a campaign. But what is the guarantee that that 4% is because of your campaign? Let's say if you're talking about Bose speakers and such things, or let's say some of these wonderful Apple brand and such things, without even advertisement and campaign also people will buy. What is the benefit of your campaign? So usually what happens is that when you are talking about a campaign, there again, this strategy is used. If there are 1,000 people, 70% of them are called as test, 30% let's say are called as test. No, sorry, 70% of them are called as test, and baki ka 30% are called as control group. Control people do not receive anything. No marketing, no telephone, nothing. And these 70% they receive mailing communication. So this is the new feature, discount, blah, 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 whatever, right? And at the end of it all, I am going to compare the performance between these two groups. If the response rate between the control and the test after doing almost all the circus is by and large the same, then what is the use of your campaign? Okay, people are responding, people are making the same level of response rate, whether I campaign or not, which means that the campaign itself is ineffective. The performance of the campaign should be assessed if its response rate is higher than the control group, or what we call as the baseline performance. Without any campaign also, if I'm getting 3%, and after campaigning I'm getting 7%, then I have a strong case and can go to the management, says, boss, the baseline performance response rate is 3%. After campaigning, I'm getting 5.5%. Now you have to tell me, statistics may say there is a strong this thing, but statistics need not be the statistics is not God. We are just pointing out certain direction. If the business says so, 2.5% is the 2.5% is attributable to your campaign. 7.5 minus 5, 2.5%. Now, is this good enough for your business? That is a question. Now you have to answer that. Statistically, there may be a significant difference, whatever be the case. Your p-value may say one story or the other, but for all these purposes, we use our what is called as A/B testing or independent sample t-test. A/B testing. Is this understood? Paired samples before and after. One benchmark analysis with a benchmark value of 322. Chi-square for relationship between categorical variables. And now this test between two groups, control versus test. Okay. Okay. I think you missed out some discussion, sir. Yeah, that I think you missed out. Okay. Okay, I'm just looking for A/B testing, or simply, right, we can call this as A/B testing. Between two groups. That word should tell you that we are comparing between two groups, A variant and the B variant. Okay, let me just show you one data set here. So I'm opening a different data set because I can't show all the things in one analysis. So please bear with me. So for different problems, we use different. I'm just slightly removing the unwanted variables so that it does not confuse us. Okay. So can you see these two variables here? Correct. You have got gender here, correct? And then you have amount of money spent in a grocery shopping exercise. Correct. Other variables and all I've checked. Gender has how many categories? Two categories. One is male and the second one is female. So when you want to, and you have amount of money spent, which is a scale variable. So you are comparing the performance between two groups. When you want to compare, obviously you need a scale variable. Right? For example, in the morning example that I gave, Go Fast Tea versus Coca-Cola FR. Two vendor performance you're comparing, or two state performance you're comparing. Control versus test you're doing. For all these things, A/B test is the one which is suited or which is tailor-made to handle these two situations. Right? Can I use A/B testing here? Yes or no? I can, right? There are two groups, males and yes. What is the average spend? That's it. No need to think so much. I can use. Why can't I use chi-square test here? We need two categorical variables. I have one categorical variables. Amount of money spent is in dollars or rupees. That is not a categorical variable. Secondly, from a business point of view, we are not trying to find out the relationship between gender and amount of money spent. We are comparing what is the average money spent between the two groups. It's a problem of comparison. It's not a problem of relation. Why can't I use one sample t-test? Where is the benchmark value? 322, any number we have? No, we don't have any value. Correct? Why can't I use paired samples t-test? Before and after, you need to have two sets of variables. Where are those two sets of variables? It is not there. So I can't use paired samples t-test. Are you able to understand why? Ask yourself when can I use this? Chi-square, two categorical variables out of question because you don't have two categorical variables. One sample t-test, it's a benchmark analysis. You need a benchmark value, one number. 322, the attrition rate is 8%. Where is that number? I don't have that number, so that is out of question. Then what is the other thing? Paired sample status. I need to have before and after. There is no, I have not used the word before and after for this problem at all. I am just comparing whether the male spend is the same as female spend. Why? Because I want to understand which of these two genders is more profitable to me. Which gender is more profitable? Are men big spenders or are women bigger spenders? That's a simple question. Can we do independent sample status for this? Right. So is the data set clear? Or shall we have coffee and come back? We'll break for coffee. Guys online, shall we break for coffee and then come back?
Yeah, sure.
Okay.
Let me open it.
Understood.
This markup says. Downgrading. It was, I guess, it was coming. It's basically, no, that is because I mounted my drive.
That is not necessary.
That's, you don't require that. That's important. The reason is you were trying to use a zero market trade. That is getting downgraded. But when you try to install this pandas profiling, it's not taking it. First, the version is this version was different. So if you want to show
Okay. Okay, guys, we'll resume. Okay. So one sample data test, that sample test, chi-square. Now for two groups we're doing. Okay. So let me just come back to this data set. Can you see here? I've just imported the data set here, right? pd.read_csv. Okay.
Just check this thing is there.
Okay. So we'll be mostly working on gender and amount spent only. Okay. A/B testing is done. Now within this A/B testing between two groups, what is that? Shopping style. Don't worry about this. Right? You don't worry about this. We just need two variables, gender and amount of money spent. So here comes our A/B testing part. See here stats.t test underscore independent.
We just use the two data points.
Yes. 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 That's it. Okay, we are comparing the amount of money spent between the two groups. Now, what this is telling you is basically, as before, you're getting the statistic value, which is not very helpful, and then the p value, which is 2.8 into 10 to the power of minus 10. 10 to the power of minus 10 is 0, very small number, correct? Can we say that? Right, it is 0.00010 zeros and then 285, right? P value is less than 0.05, so what do we do? What do we do? What do we do? There is a change. We reject the null hypothesis and conclude that there is a significant difference in the amount of money spent between male customers and female customers. So far we are clear? These three tests are clear. Benchmark, before and after A/B testing. And then in addition to it, we did the chi-square test. Okay. These four tests, correct? Now, if you have some time, we can experiment with automating ED. How do we automate it? In day one, we did manually bar chart, pie chart. Okay. Can we do a bit of automation? Huh? We just try to see how do we automate this entire EDA portion. Okay. Now this code, I've been running into some problems from the last 2 weeks. So I was just taking Amin's help, and he has sort of made certain changes to the code. So we'll try to experiment it. If we do not get this in the first attempt, don't worry about it. Maybe in the next week or subsequent to the next week, I will just try to sort of tweak the code and we can work on it, right? It has got nothing to do with the syntax, certain compatibility issues, right? So we are trying to see how do we automate ED. Okay. Slight deviation from hypothesis testing. Is it okay? If you are okay, I'll deviate. Otherwise, right? Slight bit of deviation, right? Now let's come to Google Colab. And please, all of you run this on Google Colab. In Python, in Jupyter Notebook, you'll have problems. It will not work. We will have a lot of problems. So let us open up Google Colab here, right? I hope guys online can see this. This is Google Colab. Listen. the amount of money spent between the two genders is significantly different. Correct? We are trying to automate the EDA. Let us cross our fingers. Let us see whether this code works or not. Right? If it doesn't work, I've always had problems with this particular code. It does not run at all. Last batch also, after a lot of struggle, we were able to get this. Okay. Let us see how in one shot we can automate this code. You've sent this here. Okay, Mohammed Amin. Okay. So firstly, to run this code, we need a package. We need a package which is called as Pandas. What is this? Pandas profiling package. Correct? Pandas profiling package is what we need. But that Pandas profiling package has a dependency on Pandas and the correct version of the Pandas. If the higher version of Pandas we are running, it is incompatible. Are you able to understand? Pandas packaging, the Pandas profiling is what we need to automate EDA. In one shot, you'll get all your EDA, everything you'll get. Very happy, very nice. But that has a dependency on the correct or the appropriate version of Pandas. Earlier, when I was working, it used to work on 1.0. It used to give good results. Now it is not working on that version, right? So first thing is basically let us try to check. Let us try to sort of downgrade the version of Pandas. Correct? Let us try to downgrade the version of Pandas. Okay. Profiling. Let us do a bit of circus. This is slightly twisted. It is. Okay. So we will, right? We will try to install Pandas version 1.3.5. I'm going by what Amin has suggested here, right? I'm not checked this. Okay, right? Let us just try with 1.3.5. Pip install pandas equal to 1.3.5. This is the Pandas version that we will be installing first. If you have a different version of Pandas, it will be incompatible. It will return a lot of errors. Okay, let us try with 1.3.5. Okay, so right now what am I doing? I'm changing the version of Pandas. Okay, the next line of code, what he has done is basically the markup space version. This also he's changing. This I had not changed. Markup space, markup safe equals 2.0.1. Okay, this is the second piece of code. Import pandas profile. This is the earlier code only, right? Okay, import pandas profiling. Okay. No, yeah, Gmail. I think you need to have, right? You have Google account. For Google Collab, you will get error because it will not be able to process so much of in this thing. Try this in Google Collab, sir. Try this in Google Collab. What is asking? Gmail. You don't have Gmail account. Gmail account you don't have. Gmail account you don't have. I forgot my password. Okay. We'll just see, sir. Then just see this. Ideally speaking, if you have this. So far, we are clear, guys. Everybody. Okay. These two things. And then now that I have made sure that I have the right version of pandas, I will try to import pandas profiling. Okay, thankfully it has run. Usually this stage is a big hurdle, right? Import pandas profiling. This is the package. Okay. Import pandas library. Okay. So far it's clear. He is running this on Iris. So what I will do is instead of Iris, I will just change the data set. I'll take a slightly more difficult, different data set because we will have categorical variables and everything. So let us mess it up a bit. Mess it up in the sense, let us work on uh, Titanic data set will work. Titanic. Instead of Iris, let us just say Titanic. Right, I'm just going to load a data set which is called as Titanic data set. Right, this is about, you can see here, this is the data set. People who have survived passenger class. Right, you have mixed data type. Categorical you have, numeric you have, good. In Iris you have only 4 scale variables. Right, so I'm just loading this Titanic data set. Where is this data set present? It is present in Seaborn library. Therefore, Seaborn dot load data set, within parenthesis I'm putting it as Titanic, saving it as a data frame. Yes, so far good. So far we are good. Okay. I'm just till here. Okay. Next, what do we have to do? You have done the same thing, no? I mean, EDA. I don't think you've made any changes here, correct? So you can see here within this pandas profiling, if it has imported properly, there is a function which is called as profile report. This profile report function I'm applying on DF or the data frame, and I'm saving this as an object EDA underscore report. Okay, and next stage, I'm just going to sort of export this or convert this into a HTML file. What is the error? In concat of join underscore access. So from here, it is the problem. Okay, let me just try this. For you, anybody is running? No, right? It's still okay.
I'm running.
You're able to run?
No, I'm still in. I
Okay.
try to install Panda profiling. It's not
Okay.
getting installed.
Is it getting installed?
Taking hell of a long time.
You must restart your system. Let me restart my system. Okay. Once I restart my system, now again I have to run pandas. Backup space. Cross profiling. Oh, there is a lot of errors here. This code will not run. Which one? This one? Huh? Just import, is it?
We have to run
Everything.
the kernel.
Okay.
We start with the slide.
This I have to write.
Just run the pip install.
Only this is sufficient. Okay. This itself has many. Okay. Pandas profiling 3.2.0 requires markup space 2.1.1, but you have markup space 2.0.1, which is incompatible. 2.1.1, no? 2.1.1. You have Folium, which is incompatible. Okay, this is a problem. Leave it then.
Mine
Okay,
is run.
you're able to execute this?
I can like the installation part is done for pandas profiling. It's not giving error.
Just see ed_ report whether this is running.
Can you send me the link, the code, please? So
Yes, okay.
I have to import panda profiling first, right?
Yes. You have to import pandas profiling because this function runs with pandas profiling.
It's saying import error.
Error, huh?
Importing error. It's saying.
Yeah. Error? No module. Okay, so just ignore this. This is a bit troublesome. We'll work on it separately. Huh? It is working in your system, huh? Okay, we'll just come back to Jupyter Notebook then.